All right, we are opened up to page 497 in our workbooks, and we are ready to correct our math homework from last night. Okay, so again, like I said, the website isn't working for some reason, so we're going to do it for my workbook again. I'll say it out loud because I know up there it can get a little dim. Yeah, it's not very bright. So we had number 1, 3, 5, 8, and 11 on the first page. Quickly, Zoe. So for number 1, they had you really break apart what exactly it is you're doing. So they had you first focus on the two fractions. So when we have 1 and 1/4 times 2 and a fourth, they wanted us to turn them into improper fractions first. So we would take 4 times 1 to get 4 plus 1 up at the top to get 5. So 5/4. And then 2 and 1/4, we start at the bottom. 4 times 2 is 8, plus 1 is 9. So 2 and 1/4 turns into 9/4. So 5/4 times 9/4, that's the same as taking the numerators and multiplying them, 5 times 9, and then the denominators and multiplying them, 4 times 4. When we do that, 5 times 9 gets us 45, 4 times 4 gets us 16. So we have 45/16. But that's an improper fraction because our numerator is larger than our denominator. So then we ask, how many times does 16 go into 45? Well, it goes in twice with 13 left over. So 2 and 13/16 is our answer for number 1. Show me in your hand 1 through 5. How did you feel about number 1? Okay. And Addie and Jackal, I know you guys weren't here yesterday, but I would like you following along with this as well, okay? All right, so that was number 1. Then we had, and Elena. Number 3, sorry, not number 2. Number 3, we kind of did the same thing, except it wasn't as many, they weren't having us break it down into as many steps. What they did was they had us first convert them into improper fractions, because that's one of our methods, taking our mixed number, converting it into an improper fraction, then multiplying. So we could take 3 times 5 to get 15, plus 1 is 16, so 5 and 1/3 would turn into 16/3. And then 2 and 3/4, we would take 4 times 2 to get 8, plus 3 is 11, and that would become 11/4. Then we would multiply our two numerators. 16 times 11. Can anyone tell me what 16 times 11 is? Does anyone have that work written down on their page? Allison? 176. Yep. So we would have had the improper fraction of 176 over 12. So then you would have to think, how many times does 12 go into 176? 12 goes into that 14 times. With 2 left, or with, it would be, no, they reduced it though, because our denominator was 12. So I think then it was 8/12, and then they reduced it to 2/3. Does that sound right? Yeah. So 14 and 8/12, then we can reduce to 14 and 2/3. Now, if you, on number 3, were like, whoa, Missy, those are some big numbers. Can I show you with the box, or with the partial products method, how we could do it? Can I show you that real quick? Because I know some of you, you can get to that improper fraction, but it's the simplifying of the improper fraction where you're like, oh my gosh, these are huge numbers, and now I have to divide them. If we were to do the box method with this one, and I hope everyone's paying attention, with our box method, or our partial products method, we make our box, we split it into fourths. And this is when we break up the two mixed numbers. Instead of converting them into improper fractions, we break them up. So, Jackal, are you paying attention? All right. So 5 and 1/3, I would break it into the whole number 5, and then 1/3. And then along the right, I would break 2 and 3/4 into 2, the whole number 2, and then the fraction 3/4. Then I go through and I just multiply. So 5 times 2 for this box is 10. So 5 times 2 is 10. And I'm going to circle it so I know that's the number I got here. 5 times 1/3. Does anyone know what that is? Here, let's go off to the side and do it. if I take 5 times 1/3, I'd have to put the 5 over 1. That's 5/3. I'm not going to convert it into a mixed number yet. So I'm going to keep it as that. So 5 times 1/3 equals 5/3. Sorry, that's 5/3. Then down here, 5 times 3/4. I kind of do the same thing. 5 times 3/4. That would be 15/4. Yeah, so I'm just going to put that here. And then we have 1/3 times 3/4. So 1/3 times 3/4. That gets me 3/12. Yeah, 3/12. So now I have 10 5/3, 15/4, and 3/12. So now I add up the 4 different partial products I got. I'm going to move my sticky note up a little bit so you can see it better. Like that. There we go. So then down here, I'm going to take them all. So 10 plus 5/3 plus 15/4 plus 3/12. Now, before I can add these 3 fractions, they need a what? LCD, least common denominator, right? So 3, 4, and 12, it could just be 12. Yeah, because they all go into 12. So I'm going to rewrite it down here with the new fractions. So to get to 12 from 3, I multiply by 4. So whatever I do to the denominator, I'll have to do to the top. And then for this one, to get to 12 from 4, I multiply by 3. All right, so now let's do that math. For this one, 5 times 4 is 20 over and then 12. Plus, for this one, 15 times 3 is 45. And 4 times 3 is 12. And then I can leave 3/12 as it is. And now, this is going to get me a big number. However, it's going to be easier. So, 20 plus 45 is 65. Plus 3 is 68. So 68 over 12, and then I have my 10. However, I still have an improper fraction, but is my improper fraction in the hundreds? No, it's a little bit easier to do. So then what I can do, I wrote kind of big on that post-it, so I'm going to grab the second one. Then I'm going to leave the 10 for now. I'm going to just see, okay, how many times is 12 going to 68? So 68 and 12. Well, if I count by 12, so we go 12, 24, 36. What's after 36? 48. 50. Wait.
48, 60,
60.
72.
Okay, so how many times does it go in then? How many times does it go in then? 5. Thank you. And what's 12 times 5? Yeah, there you go. So 68 minus 60 gets me 8. So I have this 5 here. That's how many times it goes in. What I would want to do, that I'm going to add on to my 10. Because if we just wrote this as a mixed number, it would be 5 and 8 12. So I need to add that 5 onto the 10. So that would be 15 and 8 12ths. But can I simplify 8 12ths? Yeah. I can divide it by 4. That gets me.
2 and 6. Then how come for the other one?
Yeah, how come for the other one we got 14 and 2/3? Did I mix up one of my numbers?
Yeah, you did.
Which one did I mix up?
Times 5.
Which one?
1/3 times 2.
Oh my gosh, you're totally right. Okay. The process is the same, but Miss E mixed up one of her numbers when she was doing her box method. Thanks, Mackenzie. Yeah. Yep, you're right. Oh, I didn't see your hand. Oh, I thought you were resting it. You saw that? Okay. Yeah, so this one should have been 1/3 times 2. I'm sorry. My apologies. But the method is the same. However, you still would have wound up with a lot easier mixed number to simplify than the 100, gosh, what was it? 170 something that you were dividing by 12. So a little easier. Yep. Okay. Any questions on 497? Okay. Then we go over to number 14 and 17 on 498. Okay, so 14 is, goodness, sorry. Here's 14. I'm going to zoom in on it a little bit. There we go. Here's number 14. So, a model of a house is built on a base that measures 7 3/4 inches wide and 9 1/5 inches long. What is the area of the model house's base? So, all that we needed to know, 5th grade, was that the base, it's a rectangle. So, we would take the width, which is 7 3/4, times the length, which is 9 1/5. And when we multiply those, we end up with 71 3/10 square inches, or inches squared, because remember, we found the area, so we need to square our unit. So we're taking what we learned with the rectangles and applying it to mixed numbers in that question. Richie.
I got 71 1/4.
Then you must have made a silly mistake when you were either adding during the box method, kind of like I did, or when you were multiplying, if you did the fractions method. Because the fact that you have 1/4 tells me you must have reduced it from something. Did you maybe have 3/12 instead of 3/10? Maybe. I could see that happening, because that would reduce to 1/4.
I might have had 2.
Oh, that may have happened too. Yes, Zoe. Oh, you weren't raising your hand? Okay. Any other questions on number 14? Okay. Then we have number 17. This one was a little tricky because there were a couple different steps. We're told that Leon and Marisol biked the Brookside Trail to the end and back. So if we look over here, the Brookside Trail is the green one. So they biked it all the way to the end, and then they biked it all the way back. Then they biked the Forest Glen Trail, that's our purple trail, all the way to the end and back. How far did they bike before they stopped to eat? So what I saw a lot of people do, and I thought this was really smart, they went over here and they put an X through the Oak Brook Trail so that they didn't accidentally add that number, because they didn't say anything about the Oak Brook Trail. So then I saw people, they thought, okay, well, I have to double both of the trails because they biked it once from start to end and then from the end to the start. So they doubled, or multiplied by 2, 3 2/3, and then 2 1/2. They got those two separate answers. Then they added them together for 12 1/3 miles. How many of you did the process to get the answer make sense? Like, you knew what you had to do. How many of you knew what you had to do? You had to double both of the trails and then add them. How many of you was the execution of the math where you may have gotten a little tripped up? Yeah, a little bit? Okay. Okay. Sounds good. Here's what we're going to do. Today, we are going to be practicing looking at a problem and being able to figure out if it's greater than, less than, or equal to. And I have some tricks that I'm going to show you for figuring that out. So go ahead in your math notebook, open up to the next clean page, please.